Welcome to Master Mathematics in Minutes. Today's topic is about the inverse of a matrix. And we'll cover a couple examples on how to apply the matrix inversion. And we'll conclude the topic with a summary. And finally, be kind and subscribe for more videos. So, what is an inverse of a matrix? Consider a matrix A with order 2 by 2, with entries A, B, C, D. We can calculate the inverse of matrix A using 3 steps. The first step is to calculate the matrix determinant, which is AD minus BC, and we'll take 1 over that. And the second step is where we swap the positions of A and D. So, in the original matrix we have A as first entry and D as the last entry. And so step 2 is where we swap the positions of A and D. And the third step is where we put a minus sign in front of B and C. And that is how we calculate the inverse of a matrix. We'll cover a couple examples on how we apply this formula. In the first example, we're asked to calculate the inverse of matrix A. And so, we have the inverse of matrix A as equals to, step 1 is where we take 1 divided by the determinant of the matrix, which is AD minus BC. So we have A as 2 multiplied by D, which is 25, minus B, which is 7, multiplied by C, which is 10. And the second step is where we swap the positions of A and D. So we have 25 as the first entry and 2 as the final entry. And the third step is where we put a minus sign for B and C. So we have 7, which is now minus 7, and 10, which is now minus 10. And so we'll simplify this expression. So the determinant is minus 20. And copy that entire matrix down. And simplifying that further, we have the inverse of A as minus 1.25 as the first entry, 0.35 as the second entry, and so on. So this is how we can find the inverse of a matrix. In the second example, we also calculate the inverse of matrix A. And so, we're given that the determinant of matrix A is equals to AD minus BC. So A is 5, D is 2, minus B, which is 1, multiplied by C, which is 10. So this determinant is equals to 0. And so, whenever we have a case where the determinant of the matrix is 0, the inverse of the matrix is not defined. And therefore, we're unable to find the inverse of matrix A. Now the reason for that is because in the previous formula, you would have seen that we're taking 1 divided by the determinant. So if you're dividing a number by 0, that is undefined. And so naturally, the inverse of that matrix will not be defined as well. In the third example, we'll also calculate the inverse of matrix I. So I is the identity matrix. It has 1s on the diagonals and 0 elsewhere. And so, the first step is to take 1 divided by the determinant of matrix I. So that is AD minus BC, with A as 1, multiplied by D, which is also 1, minus B, which is 0, multiplied by C, which is also 0. And step 2 is where we swap the positions of A and D. And step 3 is where we put a minus sign in front of B and C. So with B as 0 and C as 0, and that stays as 0 and 0, despite taking the minus signs of these. And so the determinant is basically 1. And we'll copy the matrix down, and that is also equals to the original identity matrix. So for an identity matrix, the inverse is itself. So you have I and the inverse of the matrix I as being the same. And the fourth example is where we also calculate the inverse of matrix A. And so once again, we have the inverse of matrix A as equals to, step 1 is where we take 1 divided by the determinant of the matrix, AD minus BC. So A is 2 multiplied by D, which is 4, minus B, which is 2, multiplied by C, which is 3. And step 2 is where we swap the positions of A and D. So we have 4 as the first entry and 2 as the final entry. And step 3 is where we take the minus of B and C. So 2 becomes minus 2, 3 becomes minus 3. And the determinant is 2, so we have 1 over 2. We'll copy the same matrix down. And we can simplify this by bringing the 1 over 2 inside the matrix. And that gives us 2, minus 1, minus 1.5, and 1 as the entries of the inverse of matrix A. To summarize, we've discussed the inverse of a matrix. Consider a matrix A with order 2 by 2 and entries A, B, C, D. We're able to calculate the inverse of matrix A using 3 steps. And step 1 is where we take 1 over the determinant of the matrix, AD minus BC. And step 2 is where we swap the positions of A and D. And step 3 is where we put a minus sign in front of B, and that becomes minus B, and we'll do the same for C as well, and that becomes minus C. And this gives us the inverse of matrix A. Thank you very much for watching. This is Maths Mathematics in Minutes.